And all of that is actually sort of pushing them to make some changes. And we always felt that there was going to be that pinch point where people are going to have to actually really look at the technology they're using. And that doesn't mean just the heating technology. That could be hot water technology. That's actually all sorts of fabric technology and everything else that actually gets them over the line with regards whatever the regulation states they've got to do. If I'm honest, I think without that pinch point, people just carry on doing what they're doing. You know, I watch houses go up around me all the time, and it frustrates the life out of me that many of them still haven't got solar panels on them because they're being built to old regs. But I can never understand why old regs weren't years ago. You know, I mean, it's crazy to me. But here we are. So, you know, I think even, it doesn't matter whether or not it's putting solar panels on a roof or it's actually doing anything else better with the build quality or what have you. Regulations are sort of the pinch point really of pushing that forward. There may be other logical reasons of actually sort of decarbonising, but principally, I think without the change in those regulations, nothing really much changes, you know. So, you know, that they're a lot of the relationships we've been. I mean, for the last sort of 3 odd years, we've done a lot of other projects as well. Sort of in it, you know, there's obviously within cities, you know, there's not as, let's say, much requirement for commercial space. So a lot of that is actually being switched to apartments and what have you as well, which is a perfect hunting ground for us. The system is perfectly suited for that kind of, you know, solution, for that kind of build. But yeah, I think that, you know, much of what we've done over this last while is to actually work with new builders, put in trial houses. We're launching, Level Partnership next Wednesday, actually, it goes live. We've actually built 2 houses, exactly the same, on a site there at Spennymoor. There's one, which is our heating system. It's got an air source hot water cylinder in there. It's got a couple of other bits of technology in there with regards, you know, mechanical heat ventilation and a few other bits in there as well, sort of shower, rainwater, recirculation and things like that. But that's called the Tomorrow Home, and that goes live next week. Next door, exactly the same type of house, and that's got an air source system in it, really. So effectively, it gives us a great opportunity to compare the two. You know, good. So Teesside University are actually, I'm saying literally as we speak, but they'll be finished by the end of this week, of putting in all the monitoring kit and what have you, in preparation for effectively what will be, you know, a 12-month trial. The 2 systems are very different, you know, from a variety of reasons, you know, and I'll begin to touch on sort of infrared heating, if you like, as well, and what the differences are.
I mean, that's the thing that I'd like to kind of just cover off for those people that don't know and understand what infrared heating is. Can you just break it down, just principally what it is all about?
Okay, so the easiest way I can probably explain it is the sun, if you look at it that way. So the sun generates obviously a variety of different sort of heat rays and whatever it might be. From the sun, we actually get heat, but it essentially, it doesn't heat the air at all. So the infrared energy from the sun actually comes down to Earth and it warms the Earth. And what then happens is the Earth then releases that heat. So infrared heating works in exactly the same way, or certainly the carbon film infrared heating does. Instead of actually directly warming the air, what it's doing is imparting energy into the objects within that space. And a lot of people actually, they get the misconception. They say, well, it doesn't warm the air. But it does, but it's a secondary effect as to how it warms the air. So for example, if you've actually got infrared heating in here, it's physically warming all the objects in here. That could be the brick, the table, the carpets, literally everything. And then once it gets to a temperature that you desire, essentially, the system switches off and then slowly everything releases that heat. So that's what's actually happening with infrared heating systems. The correlation of that, if you look at sort of convector heating systems like normal radiators, traditional radiators, or you know, central heating systems and what have you, they've got a heat source that's, you know, in the corner of the room, and effectively what that's doing is actually heating the air within that space. So principally, that's really the main difference. Convector heating is actually designed to heat air. Infrared heating is designed to heat objects, but they both warm the air, but just in a slightly different way. Within the spectrum of infrared heating, there's a variety of different systems, if you like. Principally 3, I think you could say. So you've got a thing called a quartz heating system, which basically is mostly what they have in pubs. People are familiar with that because they press on it if they're cold while they're having a cigarette. They're really naughty. They try and light the cigarette on the actual thing itself, but they get really hot. Yeah, and so long as you're in its orbit, then you can feel that warmth. Then you've got infrared panels, you know, and infrared panels have become very popular over the last probably 10 years, in truth, you know. But again, very different to the sort of thing that we do, because what they actually are is a solid panel. Most people put them on the wall. And the idea of actually putting them on a wall, if you've actually got a workspace or something in front of it, that it again warms you, because obviously the heat's coming out of that. They tend to get pretty hot, but in the same way that if the sun or if the earth was a couple of million miles this way, we wouldn't be here. So there's a sweet spot for infrared because of the distance it can travel. So for the wall panels, it generally is around sort of maximum 3 meters. And because of the way that it actually heats space, unless it's got something to grab onto, it can't work properly. So putting it on the wall there, for instance, by the time it's got to, it's about 3.5 meters to here, most of its energy is actually dissipated. So it has to have stuff to grab onto, really. So having it, let's say, in front of your desk while you're sort of sitting there and it's warming you, it's great. But it's very directional in the way that it works. And they get pretty hot. So their operating temperatures around sort of 90, sometimes even hotter. But certainly then effectively our system is different again. So where we install it is actually behind the plasterboard in a house. So essentially what you've actually got is where the panels, for instance here, are behind the plasterboard, there's a certain resistance value that it will work perfectly within. So effectively that energy just basically goes straight through the panel.
And doesn't lose any of its potency as it's traveling through?
It loses a little, but you'll actually get a little bit of warming. If, for instance, if you put your hand on the ceiling, it'll be warm, but it won't get to any warmer than around sort of 45, 46 degrees.
Right, okay.
So that's not where the juice is, Darren.
Yeah.
Where the juice is, if you've got a thermal camera and you actually go around the room, what you actually see is everything actually begin to actually heat up and get warm. So the way this system works, as well as opposed to an individual panel, is that we actually have about a 30% coverage across the ceiling. So it's an even heat throughout that space rather than just having it in one particular spot. So how we actually operate is that we do a design of that particular house. Each individual room, we do a calculation as to how many watts of heat requirement it is. And the way that the system actually is designed is that you've got on here. Can I show you this?
Yeah,
sure. So this is it, basically. So you'll see behind here, you've actually got effectively what are carbon molecules and a particular mixture into there. You've got a heat buzz bar here and an electric buzz bar here and one on the other side. So this one's 300 millimeters wide. We do a 500 wide as well, which we use mainly in houses because there's 600 centers between the joists. So we actually buy the heating film in from South Korea, the actual film itself, and it comes on a 75 meter roll. But we have a factory facility over in Hull where we physically manufacture all the panels. So we basically would do a design. So for instance, if we need 1,200 watts of heat within a particular space, we look at all the joist system and go, okay, a 2 meter section, whatever it might be. And we do the design for that. And the beauty of the system is that once we've done that design, it's manufactured, put in a box, the numbers and everything else are actually in place. So the electrician literally just takes it out of the box and actually then locates it into place, connects up all the connectors, which is quite simple and straightforward to do, goes to a thermostat, and effectively that's the job finished.
Right.
So
and it's this thin. This is the
right. So the actual heating film itself is that thin. This thing on the back here is a reflective insulation. So how that works is it sits on top, just directs any energy out this way. Right. It is directional anyway.
And where's the actual heating coming from? Where's the heating element?
Effectively, that is
that piece of plastic.
That piece of plastic you see there.
Can I just hold that a second?
You can. Yeah, sure.
Yeah. So for those people that are listening, I've got. I'll try and find a way of putting a picture somewhere of this. But this is like a piece of card in terms of its thickness.
It's about 0.4 of a millimeter.
Okay.
So yeah,
extremely thin. And I guess if I pull this too hard, then that's going to break it, right?
You wouldn't actually. I mean, that's just got a sticky on the back. So effectively, that's just connected to the back. But they come in two separate elements, really. So we actually, when we manufacture them, I just thought I'd bring a section in for you.
Yeah. And just so for those that are watching, there's this back element that's here, and as you can see, it's super thin. This is super impressive. And so. Where would this and how would this connect up to an energy source that would cause it to?
Okay, so if for instance on here, what you've actually got is that when we manufacture it, you've actually got effectively cables coming out of here to a T connection.
Yep.
Yeah. So, for example, if we were going to heat this space here, we might want, I don't know, we'll call it 4 sections of 2 meter sections, if you like. So when they're actually manufactured into place, you've got the cables coming out of here to a T connector. Then this T connector connects to that one, to that one, to that one. And let's say your thermostat's on that wall. The last one effectively terminates at your thermostat. So at that thermostat there, it's on its own fuse spur, and that's your room done, essentially. So these that you see here, you've got a live and neutral that is basically connected to that.
Yeah.
It's a double insulated product as well. So literally, I mean, you can fit it in a room once you take it out of the box. Take you 20 minutes.
And this is all behind the plasterboard.
It's all behind the plasterboard. So when we're actually fitting it, it literally sits between the joists. We've got a connecting, these connectors that basically put it into place. I'm not going to bore you with all the installation, but basically first fix, we actually test everything, resistance test all the panels. When we manufacture each and every one, everyone's tested in factory anyway as well.
Right.
And then we do a resistance test calculation for that entire room so that when the electrician's installing it, they can literally run a dry test on it to actually check that everything's connected up properly. And the number of beauties of it really, but once it's actually in situ, then effectively it's boarded over, another test done. Because there's no moving parts with it, effectively,
it will just stay.
It's just stay. You just work away, and that's it.
I guess the only issue will be if someone comes up with a bright idea to screw something into the ceiling. They need to be aware of where that's actually going.
Absolutely. Well, I mean, we put a schematic effectively. So we would actually have like a QR code on the consumer unit. So the customer can literally click on that. It gives them a design of what's in the house.
Right.
But the beauty of it is it's about 30% coverage of the ceiling in between these particular sections. There's plenty of room for spotlights if they want to put spotlights in, or other things like smoke alarms or whatever else it might be. I think the days of the sort of hanging wicker chair from ceilings tends to actually, but they might come back in again. Who knows?
Who knows? That with the old Christmas decoration maybe. But yeah, you're right.
Yeah.
So will that then cause an issue of a seating plan or an arrangement within a room where someone is actually in a, should we say, a cold spot or a super hot spot because they've got that infrared just kind of beaming down on the top of them?
Well, because it's equally sectioned, if you like, within the ceiling, the beauty of it is it really does. If we had it in here and you could take your thermal camera and you actually go around, you'll see the heat is
and that comes down to the design.
And that comes down to the design. And I think also as well, because the system itself doesn't get really hot, it's not designed to get hot. It's designed to impart energy into objects that then release that heat. So everything that you have within this space is actually releasing that heat, which is creating the warmth. As an individual, you'll feel it, in the same way as you sit out in the sun. If it's a cold day, you can still feel that warmth.
Yeah.
But effectively, it's actually that overall heat that's actually being released from the objects within that space. And the beauty is as well is that once it gets to temperature, it switches off and then everything slowly releases that heat. So the system itself will actually be on for 10 to 12 minutes in the hour to maintain a temperature. So it's not on all the time. It's very clever. We don't own the patents to it, regretfully. We have the licensing for UK and Northern Ireland, but I think all of Ireland actually. It's clever stuff, and very competitively priced. So I'm not here to do a pitch of obviously on this, but and I think the other thing is to say that it's a very decentralized system. So the idea is that pretty much every room within a house has its own thermostat. And as you'd naturally expect, it's all connected to Wi-Fi on phones or whatever it might be as well. So easy to control, easy to manage. So if there's bedrooms that you're not using, simply you just would put those on a frost setting, turn them down. If when you actually come downstairs in the day, and if you're going to be spending most of your time down here, everything just automatically would then turn down upstairs. So it's a way of actually managing the space a lot better.
So have you got this connected onto a similar system as a motion sensitive light? Okay. So when you walk into a room, it comes on and it's active, but when you walk out or when it doesn't recognize movement for a period of time, it will automatically switch off.
You can do that. I think lights are slightly different to heating, really. It is a reactive system, so it isn't designed to actually be on all the time. So, for example, with an air source system, broadly speaking, they're designed to actually sort of be on all the time, because it's not about flicking the switch like a boiler and suddenly everything becomes warm. So it keeps the ambient temperature continually. Whereas, I mean, you know, it will take about half an hour to take a room, let's say from 14, 15 degrees up to your 21. So it still takes a little time to warm it up. But, you know, it's designed to actually maintain a temperature, which just by clicking on and off or you know, all the time. And the key thing is that you're able to actually manage all those different areas. And also the thermostats themselves are really quite clever. I think, you know, it's like, you know, in a car, you've got loads of things that you maybe don't use or what have you. And within the thermostat, there's a lot of stuff that it does that people generally aren't aware of or don't really use. So as an example, if I set my heating, let's say within a particular room to 21 degrees, and within this, it can be a bit lower. This sort of old thing of 21 degrees tends to be gas central heating systems where you've actually got one thermostat in the hallway and that's what you're using, you know, to program it. So, but let's say it's 21 degrees. Now, I'm not going to feel much of a reduction in temperature, let's say for 2 degrees. So if I actually set it so that it will click back on again by getting to, let's say, 19, then it'll come and warm it back up again. A lot of other systems will actually sort of just be literally like this all the time. But that's not the way to actually basically get the best efficiency out of them as a consumer. So if you can't really feel that sort of 2 degree drop, or in some cases a 3 degree drop, it doesn't take a lot to get it warmed back up again. But you'll save a big chunk of money by actually managing what the thermostat can do for you. So, you know, they're all sort of Wi-Fi connected as well and what have you. So they're quite easy to actually sort of manage. You can even set it up so that when you're actually, you know, driving home, if you're, I don't know, a mile away, certain things can actually come on and off in the house and what have you. It provides the sort of setting for an ecosystem, really, because all the thermostats are actually connected to a gateway, and the gateway can enable then someone to actually add smart lighting or security systems or smart door locking systems or whatever else they actually want to actually include. We find that for new builders, they've got a lot to deal with anyway. So kitchens and tiles and bathrooms and all the rest of it. So they're doing an awful lot of that stuff. But what we're actually sort of, you know, saying is, look, it's smart enabled. So if the customer at a later date wants to actually sort of go and actually add bits too, then they can actually go and add bits too. And we don't lock the system down. You know, we work with a company called Tuya. Tuya, they manage a smart life app and they manage all these other things. So they're really the hand in the glove for a lot of that smart tech stuff. Even the stuff that some companies try and sell off as being groovy and expensive. It ain't, you know, it's just the prettier end of the market. But essentially, you know, they've got contracts with the likes of sort of GE Electric and you know, Philips and whatever it might be, of making the chips that actually sort of can manage all this stuff properly.
So how does this technology show up in a SAP calculation? How would that be
Okay,
recorded?
so essentially, currently at least, it's basically just actually rated 100% efficient, as with all other electric heating systems. The only thing that's different to that is, of course, an air source heat pump. So any electric heating systems, it's all the same currently.
So in SAP, you're going to So in SAP, this is going to be judged exactly the same as a panel wall heater.
Correct.
But the technology is very, very different.
Absolutely.
The feel of it is very, very different.
Yeah.
And the cost is different.
Yeah. This is more costly than a panel wall heater. But I mean, I'll give you sort of
So I guess what I'm talking about is a running cost as opposed to the installation cost.
Oh, the running costs are a fraction of a convective wall heater. Absolutely. You know.
But you're not then getting a full representation or an accurate representation of how it's actually performing in the building.
No, not at all.
So how do you bridge that then when you're working with the likes of Lovell and they're inputting that for the SAP calculation for them to pass building regulations, or even as you look forward to the future home standard, or how is that being overcome by them?
Okay, so I'll give you an example. Really, so we've just done some calcs on one of the Lovell houses. So in most cases, not all, if they were going to put a gas boiler in now, they'd need to put some solar panels on the roof. Not in all, I think, but in most.
Yeah, without doubt.
So essentially, all we've done is to actually put this in, and also an air source hot water cylinder. So a combination of an air source hot water cylinder, this type of heating system, with actually in this particular case, I think it required 1.5 kilowatt peak of the solar PV system, but I think it was 2 that they were already actually planning on putting on the roof. And that got them an 85B on an EPC. So it passed the regulations, no problem at all. Now, from a cost management point of view for the customer, if you like, then, you know, they don't have to service whatever the system is annually. You know, they can actually manage their heating requirement within each individual zone. In this particular house type, there was 9 zones in there. So it performs really quite well. You know, I think that at the moment, there's obviously an awful lot of promotion, if you like, of air source systems. But we're actually sort of proving to people, look, we'll work with the SAP assessors. You know, we're a bit of a different company in the sense that we're not manufacturing something and then actually selling it to a merchant who's selling it to an installer who's actually, you know, that's not our operation. So we are the sort of developer stroke manufacturer of the system, and we're talking to the, you know, technical directors of level, and we're having those conversations. And in third party, we're then actually having conversations with our SAP assessors. So in that triangle, we're actually saying, okay, well, what if we do this, or what if we do that, or how can we do this, or what have you? So we've been doing that for the last sort of 2.5, 3 years, really, Darren, and it's proved to be very useful. I think certainly from our point of view, you know, from a developmental point of view, and actually, what does it look like on site? You know, someone's got to install this stuff. You know, how are we going to make it life easy for them? You know, so hence, you know, literally doing the design, numbering everything up, so they can literally open a box, go, oh, here we go. And it's like literally a bit of a Meccano putting it together. And, you know, a qualified electrician can quite happily just do that job very simply and easily. We wanted to make life simpler, really. And that's very much around, you know, what we're about. So with regards to, you know, getting through the current SAP regulations, I mean, that particular illustration I've given you there was actually on 2013 regulations, because the house had actually obviously had the foundations in for quite some time before. So, you know, but we've actually run similar exercises with 10.2. We've started to try and actually get an understanding of what's actually in the home energy model. You know, I've downloaded the beta test, had a little look at that. I'm not a SAP assessor. You know, I did actually basically qualify as a DEA while I was with Vibrant. I thought while I was there, I may as well, you know, sitting in on the courses anyway. But I'm not a SAP assessor. So, but we work very closely with assessors to try and get a sense of actually what's coming down the track. Some of the things that appear to be apparent, I know that sounds like a bit of a, you know, contrary, but one of the things that it says in there is that they're going to measure operative temperature, which effectively is the radiant element as well as the space heating element. We're not quite sure how that will impact on this, but we think it'll be beneficial. In addition to that, when we do a design, we can actually design it to the watt, really. So we can actually work out what's the performance of that house. It requires in the living room 1,224 watts of heat. And we can actually divide that back and actually work out exactly how many linear meters are required, and we design it accordingly. What tends to happen, again, you know, in comparison to, let's say, the air source system, is that might be a 7 kilowatt system to be on the safe side. So within the home energy model, there's going to be part of it is actually giving an exact as to what system's going in. So I'll be honest, you know, none of us, I don't think, really understand exactly what the implications of all of that is or what it's going to be. But I really don't believe that the government are that naive just to say there's going to be one type of heating system in all these houses. And there's a number of other people that, you know, have got their own types of system as well, whether or not it's actually infrared panels, whether or not it's this, whether it's other types of, you know, storage heater type systems. There's a whole variety of different, you know, systems that a company can choose from. And I guess that companies will find their favorites and what works for them.
I think you're exactly right. You know, there's the people that I've spoken to over the last probably year and a half where they've said, look, we need to go down air source. Air source is the way. Sometimes they've used the word ground source, but effectively they're saying the same thing.
Yeah, sure.
And I've said, no, that's actually not the way. There is no silver bullet here that the government or anyone else is presenting. And so I think that the point that you've made there is absolutely right. And that's one of the reasons why I thought it would be so good to have you on the podcast, is just to show the listeners and the viewers out there that there is another alternative that's extremely viable, that is being used by a major developer. And I think that Lovell are really quite active in the social housing space as well.
They are indeed, yeah, sure. You know, and as I said, I mean, you know, I first met with them probably getting over 3.5 years ago, you know, so they were looking at this very, very much earlier than most other companies. Yeah, I mean, Ian Gillis, who's their technical guy up in Durham, there, he's been amazing. And you need to have that sort of relationship. You can't actually develop and really begin to understand the market and what the requirements are, in a vacuum. You've got to speak to the stakeholders in there. And obviously, there's Ian's point as to what he's looking to achieve. There's other people within the company. And there's a guy that's actually on the ground, their contractor, who's going to fit it? How's that going to work? How's this? So we've been through all of that trawl to actually develop something that really addresses all of that and actually just tries to make it as simple and straightforward as possible.
Good. Well, John, I think that now we're in a good position to go into the demolition zone, start talking about myths and start busting them.
Yeah, sure.
You ready?
Yeah, absolutely. Good. Sure.
So we're back and we're in the demolition zone, and you have created this piece of this fantastic, I use the word frequently and that's why I'm hesitating, piece of art. Probably I should use that word because it is an artistic piece. I think that you have used every single block that we've given you.
I think I have. I left out the animals. I thought it was inappropriate to include the animals.
You've left the eye as well.
I left the eye out as well,
yeah. So, predominantly here, it looks as though there are two predominant towers on a structure which is kind of fairly low level, and a number of other kind of low rise and medium rise towers. But what does it represent? Well,
I think it just represents complication, really, and not so much confusion, but complication. What we've always been about is to try and simplify, really, and it seems that the market, certainly the construction market, seems to think that it has to be complicated for it to work. And it's proved that it's just not the case. Central heating technology was developed really in about 1850. I think the first air source system, 1855. I think Westinghouse actually developed the first residential air source system in 1948 or something like that. So these are old technologies. They've actually been developed and improved over time. But, where you're looking at sort of a step change to actually how we build houses, I find it really confusing to actually then use what is technically old technology, improved indeed, but not actually sort of looking at, well, how else can we do this? Do we need to have radiators? Well, people hate radiators. Why would we have bigger radiators? Because we've actually put, an air source system in that has a flow temperature which is significantly less than it needs to be for a smaller radiator. As well as just the complexity. I mean, I've looked in, where you've actually got the hot water system, and it looks like something out of a NASA space station where you've got pipes coming out and everything else. And it's just really complicated. And honestly, it just doesn't need to be. So I think that, the myth to me is the fact that, you can build simple, really, and still very elegantly, because you get rid of a load of the nonsense that that crowds the space, and you'll meet the regs, and it'll be easier for you guys to install, and it will cost your customers less money because, these systems are, very sophisticated in how they actually operate, give you autonomy over the whole of the property, and, reduce your costs, no service costs, no ongoing, additional trauma with all of that. So, yeah, I think that, what my myth is really that life doesn't have to be that complicated. There's technology around. This stuff's been around for quite some time. It's been widespread on the continent for the last 15, 20 years. It hasn't reached these shores, mainly because we're just happy with gas. Things are changing now. And I think, whether or not it's actually government, whether or not it's actually the bodies that sit behind them as well, are tasked, rather than just listening to the lobbyists, and the people that are actually been making boilers for years, that are now pivoting into making air source systems or other similar systems. Look for simplicity. It doesn't have to be complicated, it doesn't have to be expensive. And I think that's my myth.
I love that. There is absolute beauty in simplicity.
Absolutely.
But that's great. Well, when you're ready, John, you can just destroy that myth.
There's a lot of bits to actually destroy. I feel very relaxed now.
Good. You got that off the table, literally, with a swipe of the hand. That's really good, John. I just wondered, just the last bit of time that we've got together, if you have any advice for somebody that is looking to make a difference with the way that they operate or live in a home? What advice would you give to them?
In an existing home?
Yeah, an existing home.
Yeah, sure. Well, that as far as I would say, is that a lot of newer houses tend to have sort of quite good programming, even if it's a gas central heating system.
Yeah.
And no one tends to use it. Equally, we might have 9 thermostats in a house. That handover process, if it's going to be a new home, has got to be so that the client understands it. And I think whether or not it's a new house or you're moving into an existing property, understand how it works. You've got a thermostat there. It might be one of these, Nest systems or whatever it might be. Figure it out, because it'll save you a fortune. Mm-hmm. So yeah, I think figure that out, and you'll save some money. There's lots of other things that you can do with regards to rainwater harvesting, or with regards to actually ensuring your insulation's as good as it can be, and so on and so forth. But it's only when it starts to pinch, I think, people begin to actually get really concerned about energy consumption. The last couple of years have been quite brutal for a variety of reasons, really, as to energy prices going up. So obviously people have had an eye on it. Maybe they've settled a little bit and kind of got used to it, but don't get used to it. Go and figure out how your house works. And then that way you'll save energy, save money, and actually make your contribution, probably without doing too much. You can still go on your holidays and everything else, So.
Are you currently working on a retrofit version of?
Yeah, we have a retrofit version. I think that what tends to happen, Darren, with the projects that we do, it tends to be back to brick kind of retrofit with its apartments or whatever it might be. We've got 13 apartments going in Scarborough, a 50-room HMO in Hull, at the moment. So they tend to be part of a project, really. If you've got a house, then yes, you could, essentially, it's as simple as actually cross-patterning the ceilings, making the channels, accordingly. We can do all of that.
So that's about lowering the ceiling height slightly.
Correct. Yeah, sure. And effectively, but it's a bigger job to do that. If it's actually part of a refurb, it's not a problem. Simple as. Yeah. But I wouldn't necessarily recommend someone to put this technology in if they've got a gas central heating system in, and they're quite happy with what they do, because it'd be messy, very doable.
But this is more of an alternative to air source heat pumps, ground source heat pump.
Indeed, yeah, absolutely.
Electric only.
Electric heating systems. And I think that, there's, we've done many houses that they've basically just been refurbing the house. They bought a house, they've extended it, they've done this, that, and the other. They want to rip everything out, change the system, what have you. Done loads of those, But I think, if anyone's sort of sat there thinking, I just want to just change the system, then, it's part of a bigger job, really. Okay. So yeah, but
I love the idea. I love the concept. I love the passion that you have for it and the impact that it has. And, I wish you well with the things that you're doing with Lovell. And I'm sure there's other organizations that you are or will be working with in the future.
Yeah. We've got talks with numerous organizations, but it's very much consulting with them. It's a different, for many of them, they don't necessarily clearly have a route to understanding, some really sort of, very switched on individuals, technical directors, so on and so forth. They do their job in what they do, but this is a collaboration of actually either manufacture, design, then, as I say, right the way through that supply chain as to actually, how the hell are we going to get this in? Who's going to be responsible for that bit? So we've got to understand everything in this. So it's not just a matter of actually making some panels and going to a merchant and saying, go and sell these. We've taken a very different approach, which in its way, and we probably only realized, I don't know, in the last year and odd really, that how disruptive we are being. The little old us, we're not a big team. And then we're up against some of these, big old powerful, international companies. And their model is very much, merchant, installer, whatever it might be. So we're cutting right across all of that. And it's really because we want to know. We want to develop that relationship so we can really assist them, And sometimes you sort of think it's quite a lot to bite, really. But it's pleasant. And I think we will make a difference.
Well, John, keep disrupting, keep doing your thing. And thanks
for
coming on the podcast today. And it's been great to have you.
Yeah, thank you, Darren. Thank you very much indeed.